Hello and welcome back. Today we are going to be looking at pKa values, which pKa is a measurement of acidity. And so basically when we have acids reacting with bases or acids reacting with neutral substances, we know it has reached equilibrium when there is no observable change in the concentrations of reactants and products. That is when there is truly equilibrium. And that term is defined by KEQ. Let me write that on the board. There is our KEQ with the concentration of H3O plus and the acid minus, or the acidic ion, divided by the concentration of HA, which is a regular acid, times the concentration of water. That's how we determine the point at which equilibrium will be reached. This was covered in general chemistry also. And now, so what is Ka? Well, Ka is basically when we take out this H2O term, because it doesn't matter with Ka. Ka now gets us a measure of acidity. And pKa is just a way to kind of put it into scale, just like pH instead of H, because the P basically means we're taking the negative logarithm of it to make it look simpler. And that's why something with the pH of 6 is 10 times more acidic than something with the pH of 7. Alright, so pKa or Ka is a measure of how strong an acid or how acidic a substance is. So let's do a little bit of practice to compare it. So I'm going to write a problem on the board. So first we have acetic acid. And acetic acid has a pKa of 4.75. And we also have acetone, which looks like this. And there it is, with the 3 hydrogens over there. And acetone has a pKa of 19.2. So, the question is, which one is more acidic? So, remember, the lower pKa means more acidic, because it's closer to 0, right? So, in this case, the acetic acid will be more acidic with the pKa of 4.75 rather than the acetone with the pKa of 19.2. Alright, now we're going to look at how to use pKa values to compare basicity. And that can also be used by pKb, which pKb is equal to 14 divided, 10 to the 14 divided by pKa. But most of the time, you're only given pKa and you need to find out the basicity. Well, how do we do it? How do we compare basicities with something that measures acidity? Well, basicity is the opposite of acidity. So with pKa, when we're determining which one's more acidic, we look for the lower pKa. So the more basic one will have the higher pKa. Let's take a look at an example. So there is one molecule. Now let's look at the other one. Alright, so notice how each of these, the only difference is this one's basically 2 of these stuck together. And let me give you the pKa value. So the pKa of this first one is 9.0. And the pKa of the second one is 19.2. So which one's more basic? Remember, acid, lower pKa, base, higher pKa. Which means that this one is more basic because it has a pKa of 19.2 compared to a pKa of 9. Alright, lastly we are going to look at how to make pKa values, how to use pKa values of substances to determine which direction the equilibrium is more oriented in. So, let me draw an example. Alright, so there is our reaction. And I am going to give you the pKa values of some of the things. So this one has negative 1.74. And then this one over here has negative 7.3. So which way is equilibrium going to more be oriented in? Well, equilibrium will proceed more in the direction where the pKa gets bigger, and it will proceed less in which it gets smaller. So where does the pKa get bigger? Well, notice how we're getting more negative over here. So that side is actually going to have a really tiny arrow. And the other side is going to have the bigger arrow because here pKa increases, which means that that is where equilibrium is going to occur, more towards the product side than the reactant side.